Alrighty, let's go ahead and get started. So welcome everybody out to podcast number 459. We have Brandon, the man Montero here with us, and we're going to record on audio another 10 segments of the upcoming book, Elevating Construction Surveyors. And so you'll get to share on this journey. This isn't the final book. This is just our raw voice to text that we're doing. Brandon, do you want to say hi to everybody?
Hello.
And we're going to have some fun with this, so stay with us.
This is the Elevate Construction Podcast, delivering remarkable content for workers, leaders, and companies in construction wanting to take their next step. Get ready to step out of your comfort zone with Jason Schroeder as he encourages you to do better, live a remarkable life, and expect more. Let's go.
Welcome, everybody. I hope you are doing well. I say that all the time, but I really, really mean it. So hopefully after 459 times, hopefully you're doing well, or you're going to tell somebody about it. And so if not, let us know. But we're going to get right into this because we're going to attempt to do 2, maybe even 3 sections if Brandon pushes me here today. But the first one is titled Envisioning. Ooh, real quick, let's tell everybody how this process is actually working. So Elevate Construction, we want to have, no, that's weak sauce. There's no wanting to.
Yeah. Someday, maybe.
Eventually, we'll have books out for Elevating Construction Builders, Elevating Construction Superintendents, which we already have, Elevating version 2, Elevating Construction Senior Superintendents, and Elevating Construction Field Engineers, Elevating Construction Foremen, Elevating Construction Surveyors. We already have one on the tax production system, and then BDC professionals, IPD, project engineers, project managers, logistics, and have a library. Anyone in the industry can go grab these books and take it to their next step. So we're actively working on at least 5 of those. Actually, we have 4 of them. We already have 1 done. The superintendent books, we want a revision to that. And then what we do, it's a pretty neat process, is we create an outline, which is the biggest part. Brandon and I created an outline, mainly him, and we put it into Apple Notes. And then when you put it into Apple Notes, then he typed on his own personal time, not company time, he typed intro paragraphs for each one of them. And then we get onto this platform here, we record this audio, and we'll talk together and we'll go through the story, the quote, and the implementation, right? And then what I do is I send it to, I think it's Scribby, and it does a voice to text for a decent, a really good price. I chunk it in there, and then I will go through it as a first pass with Brandon, and then the editor comes behind, and we have a book. And it actually, once it starts going, it's actually pretty fast. Brandon, any comments on your observations on what it takes to do this process?
Well, I would say one of the things that's fun about it is to think about these things during the day. So when I'm doing tasks or when I'm having experiences, Jason mentioned that I don't do any of this on company time except thinking. I still think about surveying while I'm surveying at work. But it gives me a fun opportunity to think about, wow, is what I'm doing right now a teaching moment or a teachable skill that I would like to impart? How would I do it? How would I break it down and explain it? And teaching surveying is just as enjoyable as understanding the process or being successful at work. And so it's fun for me to get to consider these things throughout the day.
I love it. Well, without further ado, let's get this done. First one, envisioning tolerances. When planning equipment and the approach, understanding the tolerance of the task is key. It is better to consider the accuracy of the equipment or the people that will follow you. If an excavator follows you, will it really dig a trench to better than 0.1? If the total task available tolerance for a wall placement is a 1/2 inch, and only people with less precise equipment will be following you in the construction process, can you really use the entire 1/2 inch for your layout? A best practice is to utilize no more than half of the available tolerance of any task And to do so, you need to understand or envision what tolerance is. And so we've been pretty accommodating, Brandon, together with each other about the outline that we follow. But generally, we want the story, settle on a quote, and then the application or challenge. So what do you have for us?
The story that I have, relatively early in my career, I worked under a surveyor. And when we were doing tasks like curb layout, he would have us set a tack in every hub, not just corners, but even points along the line, etc. And it always felt like a waste of time, but he really wanted to, create an earmark for himself of accuracy or for our work to appear accurate. But I remember being out in the field and watching people follow our layout, and they're using a curb machine, and they would set a pin at one angle point and a pin at the other angle point and pull a string between them and really ignore all of our points along the line, maybe except for grade breaks, and the curb machine would just start going. And it always made me think to myself, is the level of effort that we're putting into this work worth it? And that should be a question that we always ask ourselves, like, what is the true tolerance of the work that we're doing? What kind of equipment is going to follow our work, which can help us envision that tolerance? And do we need to dedicate more time? Do we need to dedicate less time? All of those things are super relevant into the way that we spend time on a project site.
I think that last section was good enough to be the quote. So we'll leave that as the quote. So any final challenge or application with this? Let me see if I can help with that. If you already explained the principle, what would you directly ask somebody along their survey path to do? Or what would be a practical way they could apply it?
Ask themselves whether they know what the tolerance for each task is. So when let's just say you're learning, your party chief says, for this curb layout, I'd like you to be better than 300s. Do you know that that's the true tolerance of this task? What is the logic that drives that tolerance? Do you understand the logic that drives the tolerance? Do you need to be that precise for every point? Is there wiggle room? So I would just say, do you really know what the tolerance is for each task? Have you questioned it? Do you know why it exists the way it is? And if you have the tolerance described to you, let's say from a superintendent or from someone else on the project team, how much of that tolerance are you going to use with your surveying methods?
I love that.
Let's see.
I'm
not sure. I can't remember if this comes up in one of our future segments here right now. But if your practices or your equipment tolerances by themselves eat up all of the available tolerance, then all of your work would have to be performed to a precision of 0.00, which is unlikely. So just understanding, that even knowing the tolerance might dictate what type of methods and practices you use, what type of equipment you have to use. So it's really a question that you should be asking as you plan the way that you'll attack each task.
Yeah, I love that. And we're not saying to use all of it or use none of it. We're saying be intentional about it. And you have to know what it is, right? Numbers love us and we love numbers. I think that's fantastic. Really great section. We're off to a great start. The next one is learn applied distance and angle measurement. To understand distance and angular measurement, you must have a true understanding of your equipment's capabilities. The specifications portion of your user's guide will tell you the true accuracy of each distance measurement, and for total stations, the angular accuracy is likely part of the model number itself and clearly stated. Your prism pole may have a 40, 20, or 8-minute bubble vial, and this will affect its accuracy even when perfectly calibrated. Knowing the quality of each measurement is another aid in selecting the right equipment or the best approach for each task. When more accuracy is needed, this should prompt you to consider averaging as an approach over a singular observation. And so you know the drill: story, quote, application, and challenges. Take it away.
Well, from a story perspective, I would go back to that concept of, someone performing a resection and their equipment saying that their 2-point resection was resolved to 0.00. Is that the real number, or is it just your idea of what's being shown to you? Or let's say you can, on your instrument, turn your measurement units to show 4 decimal places. Well, great. But can your instrument measure to the accuracy of 4 decimal places, or is it measuring to something, with a lot less lower tolerance? So just because we see zeros, whether we're turning an angle or shooting a distance or performing a resection, we have to think, what are the specifications of the equipment and how does that apply to the work that we're actually doing? A good example is, the prism pulse bubble vial, right? When you say plumb, it doesn't mean perfectly plumb. A plumb bob might be perfectly plumb. The rod is plumb within 40, the 40-20 or 8-minute bubble vial. Even when it's perfectly calibrated, that's how good it is. A 5-second total station is measuring to an accuracy of plus or minus 5 seconds in either direction when it's perfectly calibrated. So perfectly calibrated is still an imperfect measurement, and keeping that in mind will help us understand what best practices need to be used to do better, if better is called for from a tolerance standpoint. And it'll also help us understand how we're eating up our tolerances just with the inherent error that's in our equipment.
I don't know what the exact quote for this one should be, but there's really what comes to my mind is there's always more to the story. When you do a traverse, if you hit the precision and accuracy of that traverse, that's not the whole story. Now you get to overlay the points. When you are looking at residuals, now you can also consider the other inherent errors. When you level a level bubble, the level vial on a prism pole, and you think it's perfect, there's still more to the story. What is the actual inherent error or the accuracy of that bubble, right? When you shoot a level, what is the accuracy of that level? What are the inherent errors built in? When you have a total station and it says 0 on the angle, well, that's a 3-second gun, a 5-second gun. It can be within a range either side. So I'm going to put out the idea of, hey, there's always more to the story, but as a quote, but we can definitely correct that if you don't like it. What would be your challenge and application for this, for the people listening to this section, learning applied distance and angle measurement?
To read the specifications of your equipment, to know what you're really working with. I would go right back to, using a GPS instrument. It might tell you that your horizontal position is within 100th, and you're just like, what a great day I'm having. Every shot here is, better than 100th. Okay, but what are the specifications of the instrument? The instrument may say that it's plus or minus 400ths, 500ths in every observation. So we always want to understand, what are we really working with versus what's displayed on our data collector or instruments readout.
Oh boy, I love that. Let's do our next one. Learning double checks. There are many ways to incorporate double checks into your work, including measuring from a different direction, measuring using different equipment, having another person reobserve, and averaging as defined above. Site conditions and the distance of the measurement will play a role in selecting the above. For distances under 25 feet, a tape measure is a great resource. For less than 100 feet, a properly tensioned steel tape may be a great method. But if the site isn't clear and flat, oftentimes measuring from a different direction or averaging will be your best form of double check. Double checks may also come in the form of data comparison, such as verifying that data from the plan is or the plan set is consistent with existing conditions or consistent from one area to the plan set to another, as previously discussed. So, you know the story. What story, quote, or application do you have? I love this one.
Um,
Checks.
Well, a story that I would have is at one of our boot camps, we had a crew that was learning how to use a total station. And it just so happens that this total station had some sort of a systematic error in which it was just plain spitting out bad distances. And they were attempting to lay something out and moving the position over and over and over and over. And we're getting really frustrated with this piece of equipment. The distance that they were shooting was about 22 feet. And at any time they could have just turned an angle, sighted it with their instrument and, pulled a tape measure on flat ground or pulled a steel tape. And not only would that have double checked the accuracy of their instrument or told them which shot was correct instead of wondering which shot was correct, but it was just a great, simple and easy resource that could have cleared things up for them immediately. The quote that I would say is, everything that you do should have a double check. And I mean everything. When you're doing your measure up in the morning and you take a look at the instrument and then you look back down at the ground to make sure the tape is still over the point, and then you look back up at the instrument one time again, right? There's your double check. When you've taken a measurement, what if something went wrong? What if the person holding the rod, that's when they took their deep breath? What if something's going wrong with your prism constant? Like, are you double checking your settings? Do you have your instrument set to shoot a distance in an averaging mode versus a single shot? Could you shoot that distance from multiple directions? So my application and challenge to you would be, if the quote is everything should have a double check, when you're carrying out your processes throughout the day, ask yourself, how have I double checked this data? Maybe you are using a layout exhibit that's been created for you from the office. Are you double checking the elevations from the point file that you uploaded with the elevations from the plan set so that you're positive that these values are good? Or are you just saying, I've seen this data once and it's good enough? So that's my challenge. Ask yourself, what's the double check for what I'm doing right now? Where is it in my thought process or in my daily work plan?
I love that. The next one is learn best practices as defined. I'll go ahead and read this. I don't know if this should be looped into another section or if it's an independent, but I'll go ahead and read it right now. A best practice is a process created by taking instrument capability into account, selecting the appropriate system of double checks to eliminate potential error, and ordinating the steps in the process to eliminate wasted time, motion, and the like. Once a best practice has been determined for activities which require a special level of attention, make these best practices a standard part of your routine every time, with no deviations. Many activities, like building layout, for example, will string together the best practice methods for many processes like sighting line, turning angles, or even simple measurements. I really like this one. I would say, so learn and use best practices as defined. I like that. So you must have a story, a quote, and an application for this one. I'm looking forward to it. Go ahead.
And I want to say I don't have a story, but here's what I'm thinking. I have a really great history of not making mistakes. And it's not because I'm an awesome surveyor. It's not because I have a wide variety of experience. It's not because I'm just like super smart or photographic memory or I'm great at eyeballing things. It's because I follow best practices religiously and I don't deviate. If I know that pieces of information need to be checked, I never say, I'm so smart and so good at this with so much experience. I don't have to do that double check anymore. I don't excuse myself from the basics just because I have experience. And that is what has created, an error-free book of work for many, many, many years. It's not pressing the easy button for myself and skipping those double checks and best practices once I have defined what those best practices are.
I like that section. So quote, application, or challenge. I love it. That was really good.
Hey, I am just gonna mention that when you go up to type other things somewhere else, it moves me on my screen as well for whatever reason.
Okay. Well, I am taking notes as you go, but
Okay.
okay.
The bet. So a quote. Yeah, a quote would be, if there's something that you do on a regular basis, have you defined a best practice, or are you reinventing the wheel every day?
I like that.
You should be putting together best practices for the processes that you perform regularly. My application and challenge. Well, what I like about this section is this is where everything kind of comes together, right? Your instrument's capability. You're aware of tolerances. You have figured out what the process is for, to make things happen. So the best practice is now you string all of that understanding together. You string together the process that you've created to get it done. And then I like the concept of, eliminating wasted time, motion. That's what makes something a best practice. It can't be beat. It's flawless. It works every time. It's repeatable. Instead, what we see a lot of is just kind of reinventing the wheel every time. Or when you take a cross section of a survey department, everyone does something in their own way and it's a different way. Well, if there's a best practice, why would anyone do something a different way? If a practice has proven to be the best. And so that's why I would say, whether you're doing something as an individual or, on behalf of a department, have you identified best practices, and are you advertising and proliferating those practices within the department so that everybody can achieve the same level of success, speed, precision, whatever it might be?
I love that. Okay, the next section here is learn the data collector. The data collector takes basic layout to the next level. Using point data and line work, the data collector calculates positions, giving you the ability to offset lines, stake radials, layout stationings, and pull inquiry data such as distances between points or ID the azimuth of a line. Because it also stores data, you have the ability to record topographic mapping, as-built observations, and record as-staked positions. When performing large amounts of point calculations for layout, typically a drafting platform like AutoCAD is the fastest way to create this data from the office ahead of the work or from the field when necessary. However, there isn't much you can't do from the field right on your data collector on the fly. In fact, getting proficient with the data collector is your first step in becoming proficient in the drafting platform. Once proficient, the primary reason for selecting CAD or the data collector when performing calls will be convenience, not platform capabilities. I really like this one. You might have to dig deep on the story, but I'd love to get a story on the data collector here.
Well, I would just use a couple. This is more of a couple of examples. I remember doing a topographic survey, and I was on one side of the street and someone was on the other side. And we finished our areas before lunch. And over lunch, we were just kind of reviewing some of the work that we had done. And the person that I was working with actually was training at the time. He mentioned that he had a rod bust and that he remembered where the rod bust was and that he went and reshot that information. And in my mind, I'm thinking, okay, that probably represented 5 to 10 extra minutes of his time doing that rework. which isn't huge. But I showed him where in his data collector, he could go into his raw data, see his rod heights, and just input a line changing the rod height, and everything subsequent would have updated itself automatically. And then if you went and viewed it in the point list, everything was updated there. I remember in training the same person, shooting a whole bunch of trees. We did a lot of tree surveying. A company I worked for had a landscape architect, and we surveyed a lot of trees. And in the data collector, you could do a distance offset, which would allow you to aim first at the center of the trunk for angle, and then aim at your rod for distance. And with a robotic instrument, there was a specific way to make that work versus taking 2 shots every time, or taking a shot and then writing a long description, which is what he was doing. And the reason that I'm telling this story is he was doing things the longest way because he wasn't familiar with the data collector.
Yeah.
There was math that the data collector could do. There were changes he could make in the data collector. But instead, he was just overworking the situation because of that lack of knowledge. And another, quick story that I would say is I had an instance in which, and this is my bad for sure. I brought my laptop out to a site, but not my laptop charger, and they wanted some work done on the fly. And so I calculated a pretty big cross section of curb just using my data collector, because I had imported in my background the sight line work, the site grade tags, so that I knew where the grades were and everything. And I just did it all right there on the data collector. They're so similar to the CAD interface now that there's not a lot that you can't do. And so I would really promote, if you are someone who hasn't learned AutoCAD yet, getting to know the data collector is a great shuttle. And I'm just I'll move into the application and challenge spot, so that I'm not going on too long. If you're a person who hasn't learned AutoCAD yet, learning the data collector is the first step in that direction, because the platforms are so similar now. I would also challenge you to take the time looking through menus. It's really easy when we're in that learner phase to just do the keystrokes that our party chief tells us, or do the keystrokes that we're familiar with. But browse through menus, see what other options are available to you, what other tools are available to you, and let that create questions that you can ask to grow your knowledge in the future.
I really appreciate that. One quote suggestion for me would be that we have the opportunity to only do things that humans should do and not have to do the things that humans shouldn't have to do, right? There's so many things that a data collector can do for us, right? If people use technology to go communicate or something that a human being should be doing, that's bad. But performing the calcs and doing the great things the data collectors do, yeah, that's what a computer should be doing. Not AI and taking over as humans, but being the computer. So I really like letting let the data collector do what humans shouldn't be doing, so that we can do the things we should, right? So
Agreed.
Just a thought there, but that was a great section. This next one is one of my favorites. Learn applied traversing. The truth is, in many ways, the surveying industry has sacrificed accuracy for speed and convenience. Although GPS continues to become more and more accurate, it is nowhere near the accuracy needed for precision layout tasks such as grid lines. Definitely not at the repeatable level. For that kind of precision, traversing through your site control and recording multiple angles and distances around your figure, and then adjusting your traverse has been and remains the right method. Using spreadsheets to perform your math functions and averaging and conceptualizing the order in which you turn your doubled angles turns this system of double checks into a true best practice. And I would just say nothing has been near and dear to my heart in construction. In fact, if surveyors don't do this on a construction project, we cannot accurately or in a precise way shoot different points in for tying buildings that tie together from multiple sides of the site. I just absolutely love this concept. So let's take it away, Brandon. What do you have for us?
Let's story that I would give is I received control on a particular project from a third party that had gone out there and done the control for us. I think we'll talk about them a little bit more in the leveling because the data was terrible. And among other things, the control points didn't agree with each other, somewhere in the ballpark of 3/10 floating around, a tenth here and there, 8/10. It just was terrible. If you were to simply accept that data or, backsite one point, you'd never really understand the relation of those things to each other. So to rectify or to remedy that information, we occupied what was the stated basis of bearing, ran a traverse, adjusted it, had double check distances and double check angles everywhere around the figure, processed that, came up with adjusted data, sent it to the third party, and the third party was like, yes, we accept this. Well, of course they did. But the concept there is, how would you know? How do you know how bad things are? How do you know their true relation to each other when you have data that's not turning out well? Are you going to proliferate, kicking the can of low quality work down the road by taking, single observations or just one forward and reverse from one point? Or are you going to get the true relation of all of those points to each other? Which one of those points in this story would we have laid out the building from? There's the potential for the building to be off 3/10 or 1/10 or 8/10, depending on what we picked. And so understanding the true relation of all of those points to each other was really, really fundamental.
What do you think for a quote? What if we said, traversing your primary control for construction projects continues to be a best practice? Or what would you say?
What about the accuracy of your control is the highest degree of accuracy that you can achieve in the rest of your work?
Yeah.
Does that make sense? Right.
It leads to the need for us to traverse. I like that.
I would say in the application or challenge, to think about that fact. If you haven't traversed your work and you have 200ths floating around somewhere in your control, when you shoot your backside, it's 0.018. Are you just going to accept that? That means that now everything that you lay out from there is tentatively 200ths off. Well, what's your tolerance for this work? Is it 1/8 of an inch? Can you even do work that's sub 1/8 of an inch now on this site? Well, you can from this point repeatedly, but can you do it from any other point on the project? You really waste time in having to choose or pick where which points you occupy in the future. You really bring question into the equation of which one of these control points is the right control point. So many things, and so I would just say to think in that way is the work that I'm doing, does it need to be better than the tolerances or than the accuracy of my control? If so, apply traversing. It's really the only way to bring it all together and to have that high level of confidence in your layout work.
And if we don't do this, then not only can a point be wrong with a mistake, but also as you're laying out different buildings, most of our sites are multi-building sites, and they're not going to tie together with that bridge, that walkway, the MEP, the support MEP, whatever it is, if they're not tied together. Another little bit of advice from me on this one is that your surveyors will not think to do this. So when you contract them for your construction project or your site, it has to be in their scope, specifically lined out and required per contract for that specific work order for the money that you're paying them for them to do an applied traverse throughout the site, whether that means using least squares with redundancies or the compass rule, however it is, tying those points together is crucial. So we have to buy that out with the surveyors.
I would add to that, I mentioned that there's spreadsheets to perform math functions in there. I was a big fan of StarNet to do least squares adjustment and to be able to input all of your information. I know AutoCAD has a COGO routine that records traverse data now. There are so many different methods with which to perform this. It just makes it so worth it and so easy to utilize this method and just have that dependable work.
I love it. We are jamming. This is really good stuff. Learn as built. Things are rarely placed or constructed exactly where you stake them. Record data and tie-in points may not match the existing conditions in the field. Being able to relay as-built data from the field with precision is a multi-step process. First, the method of recording needs to support the accuracy of the task. For instance, if task tolerance was accuracy better than 0.01 feet, your process for recording the as-built needs to include methodology and support the precision measurements. Second, the information must be recorded in a way that supports the creation of an exhibit that clearly relays the data. Is the description sufficient? Does it relay direction? Does the order of collection support connectivity of the lines? Would a field sketch assist in making the work clear? So story, quote, application, and challenge for learn as built.
Well, instead of a story on this one, I just kind of want to go right back to our previous discussion on traversing. You can already see how that would spill over into everything else that you do, right? Here we are talking about as-builts. Well, is your control better than the tolerance for the as-builts? Is the tolerance of construction for a wall that you need to lay out better than the accuracy of your control to begin with? So really interesting how all of these things work together and build on each other. And it really supports that overall concept of, are you considering what best practices are, and are you utilizing them in your work? If not, your precision is questionable at best. Your repeatability is questionable at best. So many ways that all of this ties together.
I really like that. And you and I have been through a specific story, which the as-builts were from, and it wasn't us, right? So I can definitely clear that. But a set of as-builts for a particular scope of work was not recorded properly, and another portion of those as-builts were not transferred so that they had that accurate data. And I remember it impacted the completion of a project. And also, whenever we don't have correct as-builts, it is an absolute nightmare to ever do a renovation, to ever come back and understand where utilities are properly installed, or to ever really build on the things that were there previously. We have to absolutely have wonderful as-builts. Could you imagine what the industry would be like if we recorded, just like you said, accurate as-builts in a manner that it recorded them with the same accuracy that it was installed, and it was properly notated on the drawings or the as-built set? I mean, it would prevent, it's just my closing statement here, it would prevent so many hit utilities. It would prevent so much rework. It would prevent so much wasted cost for owners. It would prevent so many schedule delays. It would prevent so much rework. I mean, this is a huge, huge topic. So I hope anybody hearing this really, really takes this to heart.
I work with Oakland doing their soils disturbance permit mapping. And so I receive a lot of as-builts of different quality from vendors, from field engineers who are in the learning process. And sometimes the information that they relay isn't actually enough for us to draw any kind of a picture. There's a shot here and a shot there. Okay, I know that between those 2 points, here's where the pipe is and here's the elevation. But what happens after that? Where's the end of the pipe? Where are the bends? Are there any dips? So I would say that in our discussion, we talked about descriptions that flesh things out. Maybe you took a shot there because that's the point at which the pipe became buried. Is that information that would be useful to someone else? So just really thinking about my application and challenge on that would be to envision the way that you would shoot as-builts as if you were drawing a 3D picture. So your pencil goes down on the paper, the line starts, the line bends, the line terminates. Do you have either a shot or a description that backs up everything that your pencil did? Where the line went down, is there a shot or description? Where the bend was, is there a shot or description? Where it ends, the direction that it travels from there. If it's a T intersection, is something about what you shot depicting the physical data that you would see in a sketch, and to approach your as-builts in that way as you shoot them out of the field.
So I think I might have a good quote from the things that you already said there. What would be your closing application or challenge?
No, that was the challenge to think about the way that they record as-builts, in the way that they would put together a sketch, to make sure that they're visualizing are my as-builts sufficient for a sketch to be created, or am I just thinking I need to shoot the end of this? They want to know where the top of this is, but rather, could someone draw this completely with the information that I provided in my as-built observations?
I love that. Well, we've got 3 more here. So let me take us on to the next one. Supplemental and topographic mapping in the field. We've all seen a child's dot-to-dot, angular, rough corners. The image is clear enough to tell what it is, but not realism by any stretch. Topographic mapping is the art of recreating reality, but points need to be recorded in a way and with enough detail to accurately represent reality. That doesn't mean tons of extra time. It means extra knowledge. This is my second plug for the importance of any field surveyor getting familiar with AutoCAD. For instance, something as simple as representing a curve in the field. Are you giving the drafting technician enough data to utilize AutoCAD to draw a curve? Will the 3 points you collected make the curve appear tangent? Will it appear smooth? Or is more data needed from a field to represent it? What is the best way to shoot a wall so that the break lines and contours in AutoCAD represent reality? Does the 1/4 crown on the road need to be shot, or will shooting the striping be sufficient to convey grade? And can you see that with your eyeball? The more the surveyor in the field understands how their data is used in CAD and visualizes the drafting process, the better they will understand what is truly needed in the field. Have surveyors draft on their own work. Have CAD technicians and surveyors speak directly. Cut out the middlemen. Normalize feedback for improvement. Create training opportunities. This is a huge area of disconnect for many companies, but the path forward couldn't be more simple. I love it. Let's do this.
Man, I don't know that I have a great story for this one.
Well, I should be saying
This thing's
story.
bouncing all over.
I should be saying story, metaphor, or reflection.
Um,
Yeah.
One thing that I do want to say is I really like how all of these topics are tying together. So in as-built, thinking on a small scale about how will this be depicted, and then picking that up with topographic mapping. I guess a story that I would have is, and I know we talked about this in one of our previous podcasts. I used to work at a company, and I became good friends with their lead drafting technician. And one of the things that afforded me, which I really appreciated, was direct and, honest, brutal feedback about the quality of all work coming in, including mine. so that I could do something better. And I remember conveying that feedback to other party chiefs at that company. And they were like, well, it's not what's on the work order. Okay, but what are we doing? We're out there doing a topographic survey so that a drafting technician can draw a picture of it. And that picture is what will be given to the civil engineer. And then the civil engineer will create his design. So even though our work order has come from the civil engineer, we need to create enough data so that the drafting technician can make the product the civil engineer will ultimately use. It's kind of like, which piece of equipment is coming behind me? Well, the drafts person is coming behind me. So that's the level of effort that my work should be at, suitable for a drafts person. And so I would say this in my mind is a huge place of potential learning that really differentiates effective surveyors from mediocre surveyors. And I'm totally just saying that out loud. What that means to me is, are you communicating with the right people? Do you know that the data that you're recording is sufficient, or does it go to the drafts person and he's like, man, I hate this guy. He never does this. All of these corners look really rough. And so the drafting technician is in there smoothing things out and making your work look better than it is, and taking extra time to do that. And what all of that stems to is, how are you visualizing things in the field? Are you visualizing them by asking yourself the question, how will this be drawn? Right? We use the example of you doing it with yourself on a piece of paper with a pencil, talking about as-builts. But a topographic survey is much, much bigger. If you can't visualize how it can be drawn just yet, then you need to communicate with the person who's drawing it, get as much feedback as possible. Even better than that, I'm going to go right into the application and challenge. Draft on your own work. Whether you're the person who's responsible for it, find out if you can be the person who's going to be responsible for it. If there's a separate drafting technician, see if you can take your own work home. Connect your own dots, draw your own lines, and recreate what you did out there in the field. It will tell you immediately whether or not the work you're doing is sufficient. All of the places where you're wasting time or creating rework for someone in the office will be evident to you right there on the spot. And so I would say those are my two challenge areas. Talk to the person who's actually drafting on your work as a step one, depending on where you are in your career from a CAD standpoint. And as you're learning CAD, perfecting CAD, draft on your own work, and it will continue to teach you what the areas are where you can improve, or where you can make the process more smooth, accurate, and correct moving down the road.
I think that last statement has this summarized quote in it as well. So let's go on to the next one. Learn how to flow. On a two-man crew, no one is waiting on anyone else. The rodman has their own tasks, their own thought processes and systems of QC, their own pre-work. They have a copy of the staking exhibit and access to the plans. When the crew lead is checking in with the project team, the rodman is preparing equipment. While the instrument person is performing calcs, the rodman is QCing the cut fill they just wrote on the last lath, and then walking out to the next point to start writing up the next lath. They are ready with all the nails and the hammer as soon as the instrument person is within a couple of tenths of finding the point. The instrument person is planning the next point to lay out so that there is no backtracking, or so that the work can be easily visualized and understood. They are constantly QCing settings like rod height and prism constants, comparing grades in their data collector to the plan set, and reviewing work before they can move on. Flow means clean, clear work, constant activity, no wasted motion or time. Every item is considered or QC'd by both parties. New activities or unexpected tasks may throw a temporary wrench in the smooth flow of activities as you plan, but once a crew gets started, if you don't feel like the perfect storm just hit the site, you're doing something wrong. Absolutely amazing. Let's go.
I remember a long time ago working with someone that would just stand next to me while I was doing calcs in the data collector. I would print out 2 copies of the staking exhibit. He would fold it up and put it into his vest. He was really a person who was just there existing on the site. He wasn't thinking about what the work was. He wasn't trying to understand it. He wasn't brainstorming about what was next. He was just there. And so when I would move, he would follow me around. I'd mark a point. He'd put a nail there. I'd tell him what to write. He'd write it on the lathe. That sounds like a smooth working crew when I, explain, yeah, he followed me around. He did the nail. He wrote the lathe. Yeah, it worked. We got work done. But what if he was working while I was working? What if he was thinking about where the next point could go? He was pre-writing up portions of the lathe. He was ready with the nail as I was getting close to the spot. It would have shaved so much time off of everything that he did because we were both constantly working. There was no one waiting. There was no one with their brain in the off position, just kind of following. So I really like this concept of flow. I feel like it makes the difference between, those crews that really get in and get out when they're performing work versus stretching a task out into the whole day. It's because they really haven't hit that rhythm or that flow in the way that they work. And to me, I guess my, the quote on that would be, I mentioned if you don't feel like the perfect storm hit the site, you're doing something wrong. What's your role in that perfect storm? What could you be doing while someone else is working? There's no standing around. That particular person in my story, while I was typing on the data collector or doing calcs, he would sit down on the lathe bucket too. And I just always thought of, if I was anyone else on the project site looking over at our team, like, hey, that guy's sitting down again. Like, how does that look to other people? Versus a team that's like two people are just running around and always busy. I apologize to everyone that's listening that at the time, I wasn't confident enough as a party chief to say, I'd like you to think about how your behavior could be viewed by other people on the site. Or I feel like if you did these tasks, you're following me around, which sounds good, but if you look at it this way, how much faster could we perform things? I was training him technically, but I wasn't training him on professional concepts that really help, the flow of work, the perception of work, what makes people look like professionals. So just putting that little plug in there real quick.
You've done such a good job of explaining that. Is there any application and challenge above and beyond what you've already explained?
I'll talk about it a little bit later, but my application and challenge would be, ask yourself if each person on the crew has what they need to flow. So what might that be? Do both person have all of the tools that are necessary? An example of that is, I carry nails with me even when someone else is pounding nails, and I carry a hammer and a tape measure. And if he falls behind, when I get to that point, I'm going to go ahead and set the nail while he catches up and starts writing up the lathe. Someone's always moving. So ask yourself, does everyone have what they need to flow? Maybe that means that both people need a copy of the staking exhibit. Both people might need a plan set. Does everyone have what they need to flow?
I love that. And some of the things, the biggest thing that comes to my mind is one person's work out of balance with what both people are doing? And are there lots of starts and stops? And if there are lots of starts and stops, and if there's an imbalance in work, that means that it's not flowing. So I really, really like that. It's interesting that in scheduling systems and in production, in manufacturing plants, really the key for anything to flow is for us to get better at preparing our future tasks, to be ready for our tasks, and to be doing them well and better each time we do them. And it's funny, everything that you say, that's why we call it lean survey, leads right into those concepts of flow. Love that section. Excuse me. Last section before this little podcast is over, create intelligent exhibits. An exhibit doesn't just display facts about observations or data. It also conveys important surrounding data like, where on site is this? What surrounds this data? Information is conveyed in a clear way. That means short, to the point descriptions, statements conveying datum, dates, and other pertinent info. Any person on the construction site should be able to understand what is being conveyed, as our exhibits often travel far beyond one destination. What if our exhibit conveys a potential discrepancy? Likely, it will end up being discussed and reviewed by the whole project team, multiple trade partners, sometimes even owners. Whether our exhibit is a sketch in the field book or a CAD deliverable, as much care, attention, and effort as we showed recording the data should go into the exhibit. Remember, if the information can't be conveyed clearly, it's worthless. We must view that conveyance as an outright responsibility. Our responsibility doesn't end when the instrument case is shut. I love this one. This is our last section. Let's bring it home.
For the story on this one, I would go back to our previous discussion about the Hall of Shame. We would receive work orders that were, drawn on the back of a cocktail napkin or on some scrap of paper with a stain on it, and you'd look at the sketch, and what you were being required to do was totally, couldn't be understood from looking at that piece of information. Like, it just, no one put enough effort into it to really convey data. They were doing the least. And so I would say, when we're creating our exhibits, remember, like, you're out there surveying. No one is going to open up your raw data and understand the project. Probably most people won't be just working from your, a PNEZD as a deliverable. We need to think about the deliverable. So in creating intelligent exhibits, yes, we're shooting good points out in the field. We're shooting enough points to accurately record all of the data, but does our exhibit convey all of the data? I would also, in talking about the exhibit, could be a sketch in the field book or a CAD deliverable. You've heard that concept that your field book should be able to be understood by anybody. Maybe not just a person walking off the street, but anyone on the project site, you would hope, could open up your field book and understand, okay, you based your work on this. This is what you did. Here's a sketch of it. This sketch is not to scale, right? They can look at it and understand. Well, any exhibit that we create should be the same way. It should be created with care. It should be clear. It should convey the appropriate amount of information, not too much. It should tell them about the surroundings. They should be able to picture, where is it exactly on the project site this happened? So we just want to make sure that our exhibits are intelligent, not the least amount of thing that can be done, but as much care as was done in our field work, and as much data and precision as was recorded in our field work needs to be in those exhibits as well, because that's the ultimate deliverable.
I love it.
Let's see. Well, for the application and challenge, I would just say, ask yourself, can anyone understand this? Can anyone look at this and understand what is the purpose of this exhibit? And what is this exhibit conveying? Or would it take someone with the knowledge of surveying to decipher it? Or could only the person who asked you for the data understand the exhibit? Oftentimes, maybe we've done some sort of an as-built exhibit to compare work at a certain time, or to show, whether something is plumb or within or without tolerance. Those exhibits get passed on to third parties. They get passed on to the structural guy and the architect and the civil engineer and their draftspersons, and everyone's a lot larger circle sees your exhibits often than you would think. And so we want to make sure that we're asking ourselves if all of those parties that might utilize this data can clearly understand it, or if it's just us that can.
I love that. All right. This was a really good section. This is where you're getting more and more thorough. I love that. This book is really shaping up to be something pretty special. I always knew it would, but I didn't know it was going to be this good, quite frankly. that somebody can follow these steps and literally have the trigger to go out and learn and do whatever they need to do. So really love this, and we will see you on the next one. On we go.
Please join us next time in elevating the entire construction experience for workers, leaders, and companies coast to coast. If you're enjoying the show, please feel free to share with your construction colleagues and help us spread the word by rating, subscribing, and leaving a review on your preferred podcast listening platform. We really appreciate it. We'll catch you next time on the Elevate Construction Podcast.